Greetings, geometry students. Today we're going to begin to take a look at the basic structures of what is probably one of the more challenging topics in all of geometry, and it is the topic of two-column proofs. Please copy down the title, and let's have a look at the objectives. Our objective for today is to learn the basic structure and procedures for two-column proofs. We're just going to get some of the information in place, and then we'll look at some examples together in class. These problems are fairly lengthy to explain, so it will take us a couple of days in class to kind of walk through some stuff together before we're ready to really look at any of it on our own. The language objective is the student will demonstrate the ability to construct a two-column proof chart and fill in the basic information. Your essential question for the day: can I construct a two-column chart and fill in the basic information? As always, anytime you need more time to get something copied down, press pause and then hit play when you're ready to move on. Okay, so let's take a look. Now, first off is the word proof. A proof is a step-by-step explanation organized logically, consisting of known facts that come from definitions, postulates, theorems, and other provided information. It is proofs that the large premise of most mathematics are built upon. Okay, big, long, elaborate theorems that ultimately have to be proved that they work the way that they claim that they work. Okay, so proof is kind of like in algebra, like plugging in your variable after you solve your variable and plugging back into the problem to make sure that you have the right answer. The theorem is kind of, the proof is kind of like that to the theorem. Okay, it actually goes through and double checks and makes sure that the theorem actually does what it says that it does. Okay, now there's many styles of proofs, and we're just going to introduce you to the different styles. First off is paragraph proofs. Now, paragraph proofs spell out the argument, okay, of whatever the problem is doing in narrative form. So if you can imagine like an English paper about a math problem, that is basically what a paragraph proof does. We're not going to be messing around with paragraph proofs, and you can thank me for that later. Another type of a proof that does not show up much, it was popular for a short time, but it's called flow proofs. Flow proofs use arrows to direct the reader through the argument. Okay, you've probably seen these in some other types of classes you have, perhaps a science experiment or even in some English work and stuff like that, where you call them flow charts. Same idea, but it's a flow proof. Okay, so you have kind of bubbles and boxes and then arrows that direct you from one box to the next based upon what the particular problem is trying to do. So that would be a flow proof, and we're not going to mess with those really at all. And then we have two-column proofs. Two-column proofs use matching statements and reasons to complete an argument. Now, this is written in chart form and largely written in short, choppy information that is basically like sentence fragments and identification of particular terms and rules. It's mostly an organizational system in order to get all of our thought processes and step-by-steps kind of organized logically as we move our way through the problem. It's the easiest of the three different types to understand. That's where we will be focusing. All of our information in geometry will be with two-column proofs. Now, the key with proofs, and this is the part that really tends to bother people when it comes down to proofs, is you're not allowed to simply know or understand anything. And let me explain to you what I mean by that. Every step that we take in a problem, every statement that we make to get from one step of a problem to the next step of a problem, we have to actually take the time to spell out our reasoning. Okay, so everything that we do, every time we move from one line of a problem to the next line of a problem, there has to be a justifiable mathematical argument that can take you from one step to the next. You're not allowed to simply know it in your mind that that's the way it works. Okay, you can't presume that anything is simply known by you or by whomever happens to be reading your proof. So basically what we're doing is we are spelling out every step that we do in a problem with great detail as if our reader had no prior mathematical knowledge at all. So it's kind of like explaining it to somebody that has never seen it before, and there has to be a reason for everything that we say. So if we say, okay, on this one you're going to do this step, and they say why, you've got to have an answer to the question why in a proof. Now, the structure of a two-column proof should be no great mystery. It's basically a little T-chart that has two columns in it. Information that we call statements are going to be all the way down the left column of the two-column proof. Information that we call the reasons are going to be all the way down the right column of the two-column proof. In the statements column, this is where we will be working our problems. This is where we will be discovering new information to discuss with whomever the reader of our proofs are. Okay, here we state new information based upon the things that we know about the problem. Okay, so a different way of thinking about the statements is kind of like the area of discovery, okay, where we are discovering new things about the problem, discovering the next step of the problem, trying to get from the beginning of the problem to the end. All of that is the statements. So a way to think about that also is kind of like when you've been working problems out on paper, step by step by step, the statements column is where that problem belongs as it moves step by step by step. The part of this that is new is over on the right side. For every single statement that we make, there must be a reason we were able to make that statement. So every statement has to be justified with solid mathematical information. Now, where are we going to get solid mathematical information from? Well, we have a lifetime of it. We've learned of all kinds of rules, and we've refreshed certain properties in our minds here lately, and all those rules and all those properties come into play so that any time we take a step and make a new statement, we will be able to say, the reason I made that statement is because of the distributive property or the symmetric property, things like that. With every problem that we run across, there is a place to start and a place to end. And actually, as you get higher in mathematics, knowing where to start and knowing where to end, those are actually very critical pieces of information. And you'd be surprised how much information you can fill in the middle of a problem if you simply know where to start and then where to finish. With proofs, some information is going to be provided for you about the problems. The first thing that you are going to do with a two-column proof is rewrite the information that they provide you in the statements part of the two-column chart. Now, there's a lot of different ways that they can communicate information with us, and we've already discussed a few of them as this year has unfolded so far. They can give us diagrams, and information can be revealed in those diagrams with things like tick marks and angle congruency marks and adjacent angles and right angles and things like that. And they can also provide some external information about the diagram. So they have a picture, or possibly even not a picture, but then they have a bunch of statements talking about what's going on with a picture. If they gave us one or not, they can state information about it. So everything they give us is going to be rewritten in the statements part of our two-column chart. Okay. Now it seems really silly. Why would we have to take time to write down things that they already told us? Well, the answer is I've already discussed that. Okay, we're not allowed to simply know anything. Every statement that we make, every piece of logic that we use to get from the beginning of the problem to the end of the problem has to be spelled out as if the person that's reading it doesn't have any understanding of what's actually going on. Now, as we said, everything that we say must have solid mathematical reasons for those statements. Okay, the reason that we have for being able to write down that information that they told us, either by way of the diagram or the external information near the diagram, the simple reason for that is given. We don't know where it came from. We don't know what they saw that led them to believe that that information was true. But since it was provided for us by the diagram, it is true by whomever constructed the diagram. So when it comes time to actually fill in information in the chart, we are going to write given next to that type of information that shows up in the reasons column. Okay, so when it comes time to start filling out our column and the statements, the first thing you're going to do is you are going to write down everything that they told us about the diagram, and then you are going to state given. So if they gave you one piece of information about the diagram or in the diagram, you'll have one statement and it'll say given in the reasons category. If they gave you two pieces of information, then you'll have two things written in the statements column, and then you'll have two entries in the reasons column that both say given. If they gave you 10 things in the statements, then you're going to have 10 reasons that all say given. Okay, as with all math problems, we have a goal. Okay, something that we're supposed to do. We're supposed to solve or simplify or prove, something like that. And that's where proofs are in play. We're supposed to prove, which means verify, something about a diagram. Now they are going to tell us what it is that they want us to verify. Usually that means that a particular length in a diagram is a certain value, or a particular angle has a certain measurement, or perhaps we're going to be proving that two things are congruent to each other or similar to each other. Anything that we do in geometry is a potential proof problem. So anything we're asked to solve, we could also be asked to prove. Okay, so we're going to be told what it is that we are supposed to prove. Now the problem of the two-column proof will not be over until you make the last statement and provide the final reason to go along with that statement. Now, if you are able to complete your proof, then whatever it is they told you to prove, that should be your last statement. Because if you're able to reach that point, that should be the place where the problem is actually over. So once you get to the point where you're actually able to write down what they were told us to prove, your problem should be done. The only thing left to do would be to provide the final reason. Okay, so here's the chart. You can just add this information to the previous chart that you already drew. Okay, we're going to write down whatever information they gave us as our first statements. The reasons for those will be given. And then we are going to, the last statement that is going to show up will be whatever it is that they are asking us to prove for that problem. Now, obviously, there's got to be some information in this statements column between those two sentences that you see now, because we've got to get step by step by step from the first statements to the final statement, and we've got to do that logically. So clearly a lot of information is missing from what you're looking at right now. Now, one of the biggest mistakes people make is we always have this argument. People always seem to think that if the first statements are given, that means the last statement is proven, and that is absolutely never, ever the case. Okay, you will never use the word proven as a reason in a proof. Okay, that's basically where we're at right now on the structure. Okay, so whether you know anything about a proof or not, you will be able to fill out those 3 particular spots in the proof, and that's not going to get you a lot of credit, but it's at least a starting place, and hopefully you'll be able to connect some of the other information. All of the rest of the information for the proof is going to have to come from you and your brain. So again, proofs can show up with pretty much any geometry problem. So anytime we add a new definition or a new rule or a new formula or anything like that, that is all fair game to show up in proof type problems. Okay. At the beginning of the proof, you're going to have to get certain things. We've already mentioned a couple of them. Usually they give you a diagram. Most of the time with proofs, they're going to draw you some kind of a picture. They're also possibly going to give you some additional information with the diagram, which is typically labeled on near the diagram as given information. Okay, as we told you that a lot of times if they cannot draw the diagram without cluttering it up with too much information, a lot of times they will write it beside the diagram, in this case with a proof that is called given information. And they're going to have to tell us what it is that they want us to prove. They can't just give us a diagram and turn us loose without a goal for the problem. So they're going to have to tell us what it is that we're supposed to prove. Now, as I stated, this is going to be kind of a long endeavor as we become acclimated with the idea of 2-column proofs. I'm not going to give you any examples in the notes because, in all honesty, it is simply it's too much information. Okay, we're going to have to work through several together in class and try to get the idea of how these things work. Okay, so go ahead and wrap it up with a little bit of a summary. Jot down any questions that you may have regarding this lesson. And of course, always keep your essential question in the back of your mind. In this case, that is, can I construct a 2-column chart and fill in the basic information?